Today we'll look at another collection from the Java standard library, LinkedList. In practice, it's used infrequently, but it's asked about in interviews all the time. It's one of the most popular interview questions. What's the difference between array list and linked list collections? Today we'll find it out. The structure of this collection is quite difficult to understand because when we deal with a set of data, we always imagine an array. That is an object where all elements are allocated one after another. But linked list is arranged differently. Arrays are not used in its implementation. Imagine a queue at the checkout at store. All customers are standing one after another. Just by looking at this queue, can you say who is the third in line? Of course you can, that's easy. All elements allocated in a row. So the third person will have index 2. You can answer this question right away with no problem. We talked about this in the previous lesson. The complexity of getting an element by index in the collection array list is O of 1. Now what if someone wants to get in line at the end of the queue? Does this create any problems for others? No, he just gets in line at the end. We also talked about this. The complexity of adding an element to the end of the collection is O of 1. It's done in constant time. Now imagine that someone is in great hurry and asks to be led into the front of the queue. Can he do that without disturbing anyone? No, he will have to ask everyone to move to the left. And when the space is freed, he will be able to stand in that spot. The complexity of inserting specifying index is in this case O of 1. Now when this person has been served, he leaves the queue. In other words, we remove him from the collection. What will the others do? They all will have to shift to the right. And the complexity of deletion is also O of n. You're watching a video from our Kotlin programming course. I've left a link to the full version of the course as well as the biggest discount available in the video description and in the pinned comment. Enjoy watching. So inserting elements by index, as well as deleting them, takes a long time. And developers began to wonder, is it possible to create a collection where the separations are performed quickly? Then they came up with a new type of collection called the linked list. To understand how it works, let's again imagine a queue. Not in a store, but in an old hospital. Early in the morning, when no one is there yet, a grandma comes to reserve a place in line. She asks who's last. No one answers, so she understands that she's the first, and happily sits down to wait for the registration desk to open. Sometime later, another person comes and asks who's last. The grandma replies that she is, and the person says that they will be after her and takes a seat in the waiting room. This happens many times, and over time the room fills up. Now, just by looking at this room, could you tell who is the fifth in line? No, everyone is sitting randomly. Everyone knows that the grandma is first, and that's all. The rest is not so clear. The only way to find the fifth person in the queue is to ask the first person in this collection, the grandma. We can ask who's next after you. She will point to the next. You'll come up to this person and ask the same question. And he will point to the next person. Eventually, you will find the fifth person in the queue. This is how the collection linked list is structured. There are no arrays. There are objects, and each has a reference to the next element. Right away, we can only guess the value who is first in the collection and who is last. And to get an object by some index, you need to go from one object to another, asking who's next. So getting an element by index in this collection has a complexity O of n. You might wonder, what's the advantage here if in the array collection, getting by index was instant, done in constant time, and here it becomes O of n. And you would be right. For this specific operation there is no advantage. In fact, it's quite the opposite. If you often need to get an element by index, it will take much longer in a linked list than an array list. But every collection has its pros and cons. What if we insert a new element at the end of the collection? The next person will simply ask who is last, and tells that person they'll be after them. So just like an array list, insertion at the end of the list is done in constant time, O of 1. Now comes a student who simply needs to ask a question. He wants to get at the very front of the queue, that is, be added to the collection at index 0. In this case, he doesn't need to disturb the whole queue. All he needs is to make an agreement with the grandma. Speaking in terms of programming, the references need to be rewritten. Now the student becomes the first in line. And if someone asks who goes after him, he should say grandma. The rest of the line doesn't change at all. No one changes their places in the computer's memory or rewrites references. These objects don't even know that something has changed. So when inserting an element at the beginning of the collection with a specified index, we no longer care about the size of the collection. This is done in constant time, and the complexity of insertion with a specified index now becomes O of 1. Now what happens when the registration desk starts working? The student should be served and will be removed from the queue. All that needs to be done is to rewrite the references. Now the grandma becomes the first element in the collection, and we don't need to touch the others. No other actions are required. So the complexity of removing an element by index becomes O of 1. Now let's say all this in technical terms. ArrayList is based on an array. Meanwhile, LinkedList uses links. There are no arrays here, only objects that store references to the next objects. And due to this, there are certain disadvantages in this collection, but also advantages. The first disadvantage is that if you want to get an object by some index, then you need to get a reference from the first object to the next, and then from the second, third, and so on. So the complexity of accessing an object by index is linear, O of n. When inserting an element with a specified index, you no longer need to shift all elements anywhere. All that needs to be done is to rewrite the references. That's why insertion with a specified index is done in constant time, O of 1. Please note that now we are talking specifically about inserting or deleting objects at the beginning or end of the collection. In this case, the complexity will be O of 1. If we do this somewhere in the middle of the collection, the situation will differ. And how exactly we will find out in the following lessons, when we write the implementation of this collection in code. If this topic is quite clear to you, you can move on. See you in the next lesson.